Welcome back to the deep dive. Today, we've got something really special, a stunning new image from Hubble.
That's right. We're talking about Abell 209.
Exactly. Abell 209, it's this colossal galaxy cluster, right? Like incredibly far away.
Yeah, about 2.8 billion light years. Just think about that distance for a second.
It's mind-boggling. And the amazing part, its gravity is so immense it actually like warps space-time.
It does. It's a perfect example of general relativity in action on a grand scale.
So our mission today is to sort of unpack this. How does looking at Abell 209 help us understand, well, the invisible bits of the universe, the stuff we can't see?
Right, and there's a lot of that. So Abell 209 itself, you can think of it as a kind of galactic megacity. It's in the constellation Cetus.
A megacity, I like that.
Yeah.
Yeah.
And Hubble sees, well over 100 bright galaxies packed in there. But like you said, that visible light, that's just the tip of the iceberg.
Okay, so what else is there, the invisible stuff?
Well, first, there's this incredibly hot, thin gas spread out between the galaxies.
Hot gas? How do we even know it's there if it's invisible to Hubble?
Good question. We can't see it in visible light, but it's so hot, millions of degrees, that it shines brightly in X-rays. So X-ray telescopes can pick it up.
Ah, okay. Different kinds of light. Makes sense. But that's still normal matter, right? Just hot gas.
It is. It's part of that small percentage of the universe we sort of understand. But then you get the real heavy hitters, dark matter and dark energy.
Right, the big mysteries.
Exactly. The current picture, roughly, is like 5% normal matter, stars, gas, planets, us. Then maybe 25% dark matter, and the rest, around 70%, is dark energy.
70%? Wow. Okay, and focus on dark matter for a sec. It's invisible, doesn't interact with light.
Correct. At all. We think it's probably some kind of particle we haven't detected yet, but it's gravity. That's very real. In a cluster like Abell 209, there's about 5 times more mass in dark matter than in all the stars and gas combined.
5 times more. So how on earth do you study something like that? If you can't see it, it sounds almost impossible. Are we just guessing?
Not guessing, no. We use a really clever trick of nature called gravitational lensing.
Gravitational lensing. Okay, I've heard of this. It's like a cosmic magnifying glass.
That's a great way to think about it, because Abell 209 is so massive, mostly due to that dark matter, its gravity bends the path of light coming from galaxies behind it.
So the light from even more distant stuff gets distorted as it passes by the cluster.
Precisely. Now, Abell 209 doesn't create those really dramatic, perfect circles of light Einstein rings, we call them.
Right, I've seen pictures of those. Amazing.
They are. But even without perfect rings, you can see subtle effects. If you look closely at the Hubble image of Abell 209, some of the distant galaxies in the background look a bit stretched or curved, little streaks.
Okay, I think I see what you mean. Tiny distortions.
Tiny, but measurable. And by carefully measuring how those background galaxy images are distorted, astronomers can work backwards. They can essentially map out the gravity field of the cluster.
And since most of the gravity comes from dark matter.
You map the dark matter. You can figure out where it is and how much of it there is. It's like weighing something invisible just by seeing how it bends the light around it.
That is seriously ingenious. And Hubble's sharp vision is key for seeing those tiny distortions, I guess.
Absolutely critical. Hubble's resolution lets us pick out those subtle lensing features. And this data, from Abell 209 and other clusters, it's not just showing us that dark matter exists, it's showing us how it's clumped together.
Clumped. So it's not just smoothly spread out.
No, it seems to form this vast invisible scaffolding. And the galaxies we see, they basically form and live within the densest parts of that dark matter scaffolding. Understanding this structure is vital for testing our models of how the entire universe evolved over billions of years.
So when we look deep into something like Abell 209, what's the big takeaway for us listening?
Well, it's a powerful reminder, isn't it? That what we see with our eyes, or even our best telescopes in visible light, is just a tiny fraction of reality.
Yeah, that 95% invisible statistic is always stunning.
It really puts things in perspective. And it leads you to wonder,
Yeah.
if most of the universe is made of stuff we can barely detect, what other fundamental things about space-time, about reality itself, might we be missing? What else is hiding in these subtle clues, these tiny distortions of light from across the cosmos?
That's a great question to ponder. How much more is out there that we haven't even conceived of yet?
Exactly. There's still so much to learn.
A perfect thought to end on. That's all the time we have for this deep dive.